We now have Mr. Corey Maltby and Mr. Craig Gallen from Solent University and Entimos and Solent University, respectively, telling us all about telecoms inventory for GPON using Kuwaba. Did I get that right?
That's right. Very good. Thank you.
Much.
So I'm Craig. This is Corey. Corey's a student. He's looking for a job. Anybody interested in employing him after this? Very keen. I'm going to talk a little bit about what we've been doing in the last few months at Solent University. And I'm going to just jump in and say, what's the motivation for this? Well, the problem with operational support systems and telecoms in general for a university student is that they don't have any idea of the scale. They might do a little bit about data centers, but they don't know what happens in a large-scale, millions of customers environment. So we're trying to create an environment where we can teach something around that. And I'm working with a colleague in Australia who runs a little company called Passionate About OSS, and he's come up with this idea of an operational support system sandbox, and to use that for teaching and for also demonstrating to potential customers of different technologies. Now, one of the key parts of that sandbox is something called Kuwaba, which I'm sure none of you will ever have heard of, but is an open source inventory system designed for telecoms. And it's used in South America by a number of service providers. It's actually developed out of Colombia in South America. And I came across it, and simultaneously Jeff from Passion About OSS came across it. And we thought this could be a great tool both for actually demonstrating and teaching around OSS inventory, but also actually we think that service providers might be quite interested in this if they knew anything about it. So what is Kuwaba? Well, it's a soup-to-nuts inventory system, inventory of services, IP addresses, physical and logical components, and it's an extensible model that you can extend to any components that you have in your network. And having actually modeled the physical part of your network, you can then model circuits across the network. Now, we've been doing some work separately to this with one of the large UK GPON service providers to use OpenNMS to do correlation of alarms across the GPON network. And we did some fantastic work, but we couldn't tell anybody about it because the network itself was proprietary. So what we thought we would do is could we construct in Kuwaba a representative telecoms network and use that to drive experiments using MCP and AI and other things to actually correlate alarms across the network using a real inventory. So we have in Southampton a project, or a module, which is a consulting module where companies come in with ideas and things they'd like to do. And we did a consulting project using students, 7 final year students, for 3 months to come up with a solution. And what we're trying to do is build on this previous work, modeling a GPON network, but now try and build a representative GPON network using data from OpenStreetMap and UPRN data from the Ordnance Survey. So I'm going to hand over to Corey, who's going to tell you all the complicated detail of that.
So basically, the project itself is designed to work anywhere in the UK with OpenStreetMap data and UPRNs. To actually develop the project, we looked at this small area in Southampton called Bitton Park. And then when we came to testing that, we scaled up to larger areas like Winchester, the Isle of Wight, and then eventually the whole county of Hampshire. We did have to exclude a few things. For example, we assumed that there was no infrastructure before which we could use, and we also assumed the network was completely flat. So the whole application itself is contained within a Docker stack. We first import the data within a container, and then all the data relevant is linked to UPRNs. So we use a Spring Boot application for this, and you import the data is imported, and then it's put into the schema, which is initialized on startup. So we also, to look at the data cleaning itself, so the OSN data can have quite a lot of things, like there's just, all that we need for this is just the buildings and the roads, and then we deleted any of the metadata which we didn't need. We then put this into the tables required. Then we ensured they put it in a fresh database so it's clean for the infrastructure prediction. So the infrastructure prediction itself uses a PostGIS Q-means clustering. If we have 12 buildings connected just to a single pole, and then one of the 8 of those poles connects to a single cabinet, and that would scale up all the way up to an exchange level. So then to actually make the network, we place the network hardware down as nodes, and then connected them using Dijkstra's shortest path algorithm. If that ever failed, we'd just draw a direct line between the artifact itself and the drop point. Each building itself has a drop point, which we generated during the importing. As you can see here, we got a photo of the network itself predicted using QGIS here. So each building has its own drop point, and then they're connected to the artifact. Any underground cables follow the road directly. Yeah, I think that's it.
Yeah, I think so. We've got a demo. So if you could roll the video of the demo now, please. Hopefully it'll become a little bit more easier to understand when you actually see that.
In this video, I'm going to show you how the Kuwaba OpenStreetMap tool is used. You can see here the front page of the tool, and we can see that there are 2 sub-pages, one for importing from a map, and the other is a Swagger page that allows us to control various aspects of the demonstration. If I go first of all to the importer page, I can select an area. Now we can see that this map is just taken from OpenStreetMap. I'm going to select an area to import around Bittern Park, and I'm going to import the area. Now once the area is imported, I'm now in a position to start predicting the placing of poles, cabinets and circuits in this particular network. To do that, I will go to the Swagger UI, and I will go to this prediction controller panel, and I'm going to predict all of the areas within that particular map. So here we can see QGIS, which is a way of displaying the data in our Postgres database. And I can see on this, these are the noted streets that we've exported. And I can look at the buildings that I have exported as well from my area. If I zoom in a little bit, if I now put the building drop points on, we can see these are the points nearest to the road where the building is going to be connected to the fiber. And if I put in the network points, we can now see these are the telephone poles or street cabinets that are along the path that the fiber is taking. And finally, if you put in the network connections and take out the noted streets, we can see that these fiber points have been put in automatically. Now we're going to export this data, having created it. And to do that, we go back to the Swagger UI, and in this case, we're going to look at the requisition connections. I'm only going to export 500 of these connections because it will take a long time to import if I do any more than that. And if I execute that query, you can see that I actually have a JSON file which is used to import the templates and the buildings and objects, and also, if we go further down, the actual connections between A and B that are in this network. So that file can then be imported into Kuwaba. And we do that by simply placing the file in a known location within the container that Kuwaba is running on. And if we start Kuwaba, we can actually import the file by using the task manager. And within the task manager, we have a provisioning task, which basically runs a Groovy script that imports that data. If we run that script, I've already run it, so I won't run it again, we can then see the things that have been imported. So if I go to the root of the model, there is other data in this particular model because it's the standard model that we use to demonstrate Kuwaba. But on top of that, we've added the United Kingdom, and within our example, we've put in Bittern Park. And if we jump down, we can see within Bittern Park, we now have all of these roads, and if we just pick a road at random, you'll see that there are houses on that road, and each house contains a splice box, which is the point at which the fibre is connected to the house, and then from that we go to the ONT, which is a Nokia ONT. We can jump down and see the Nokia ONT, which is an optical port and an electrical port on it. I'm going to look at a wire container between 2 points. And if we look at that in more detail, you can see that this wire container, which goes between the exchange and one of the aggregators, has 4 containers, which then contain 12 fibers each. So that's a standard blown fiber unit that can contain these fibers. If I now want to show those fibers connecting from end to end within the network, I can pick my point in the exchange. I'll pick this particular device, and I'm going to pick this particular aggregator, and I'm going to look at the splitter in the aggregator, and I'm going to look at the in port. So I'm going out from the optical port on the OLT, through the fiber, and in on the first splitter. And if I connect both sides, that's how we connect the network together. So this particular trunk has been generated for us. The aggregator and the exchange have been generated for us using templates, but we haven't got the end-to-end circuits. Those have to be manually added. We could, in the future, also add those automatically if we wished, but for now, we're leaving it as a system that allows you to create those circuits on demand as you do it yourself. Now, if we look at the actual facts again, go back to the fiber exchange here, and again, I want to look at this device. So let's look at the fax rack. Now we can see that we can actually view a rack view of that rack, in which case we can see where in the rack those devices are positioned. We can also jump down into a device and see the passive optical portion. We can see this is blue, which means it's connected to something. And what I'm going to do is look at the physical tree view, which is going to show me what this particular port on the OLT is connected to in the network.
Okay, so that was a quick demo. Basically, we've got a working solution which you can download from Github. It all works, as you've seen in the demo, and it's useful as a tool for people to play with. We want to take that a bit further in terms of improving that importer, but we also then want to begin to use that for a wider OSS sandbox. OpenNMS itself is going through evolution. We're turning it into a microservices architecture. It runs cloud native. We want to hook that up to this GPON network and do a demonstrator of how we can manage a very large-scale GPON network using that. And in the future, we'd like to add an MSP onto the Kuwaba infrastructure so we can get data out into AI. And at the same time, if we can get data out of the fault management infrastructure into the AI, we can do some clever stuff using large language models. So that's where we want to go with this. But for now, that's where we're at. So thank you very much for your attention.